Hey guys, welcome back to your very own Mass Coder. Hope you're doing extremely well. So as you can see, it's a 25th day of solving the GFG POTDs. Okay, so today's problem is search pattern through KMP algorithm. Okay, search pattern means that you have been given a string S and you have been given a pattern P. You have to tell all the indices in S where you can find P. Suppose your S is 5 times A, B, and your P is 4 times A. So as you can see that 4 times, sorry, I have drawn an extra A here. Yeah. So you can see that 4 times A is coming once at the 0th index and second time at the first index, and this is your only answer. Okay. So without wasting any time, let's move to the brute force approach. So what is the brute force approach? That again calculate all substrings of pattern length. Try to compare them with pattern and accordingly put your answer. Compare them with pattern, and if matched, update your answer. Else, if matched, update your answer. Else, what you can do? Move to next substring. Okay. So what is the root force approach? To find all the substrings and then try to compare them with the pattern. How will this work? The pseudocode will look something like this. For I going from 0 up till, as you can see, I've got a length of 4. So for 4 length, I have to stop here. That is n minus 1, 2, 3, 4. That is n minus p length. Okay. If s dot substr, I'm using the substr function to calculate the string. I up till pattern dot length equals to pattern. In that case, answer dot pushback I. All right. This will be your pseudocode. But what is the time complexity? As you can see, it will move for approximately O of n times. And substr uses O of n to complexity. So you are seeing you are making a substring of length m, and it will be operated n times. So the total complexity is m into n, very high. How can we reduce it? How can we make it linear? That's when KMP algorithms work comes in. KMP algorithm. It states that in the above example you were given A, and this pattern was given to you was 4 times A. So what were you doing? You were checking A. Checked. Okay. Put in the answer, that is 0. Now you moving with the whole pattern for the next index. But if you see that if this is matched, doesn't that guarantee that for the next string these three are already matched? Pay attention. If this whole string is matched, okay, doesn't that guarantee that this string is perfect match for the next for this substring? As you can see, this substring is come here, so 3 is done. If we check it one more time only, if we check for one more a, we will get an answer, correct? So it is somehow using the concept of longest proper prefix and suffix. For those of you who do not know what this problem is, no problem, I will tell you in this very video. Okay, just stay with me, focus with me. So our prerequisite is this. If we do not know this, we have to learn this first, then we can move to the KMP algorithm. Okay. So let us move to the new problem, that is longest prefix and suffix. Longest common proper prefix with suffix and suffix. The problem says, suppose you have a string A, B, C, D. You have to construct an array related to each index. So there are seven places here. So 0, 1, 2, 3, 4, 5, 6, 7 indices here. Okay. So as you can see, this string is simple. Proper prefix is, what is the meaning of proper prefix? Prefix of length less than length of input string. All right. So the proper prefix for this one is only the empty string. Okay. So this will be zero all times. This is the base condition. Okay, guys. Just remember it. This is the base condition that it will be zero always. Okay. Moving to the next index, next prefix will be AB. Proper prefixes possible are zero, that is empty string, or simple A. But simple A is not equal to suffix here, so AB is not a not so zero will come here also. Similarly for ABC also, but for ABC A, you can see this is this matching, and the answer will be one. The answer would be one here. Okay, now for B part, AB matches AB, two comes here. Then ABC matches ABC, three comes here. But for D, no, no luck here also, so it will be zero again. So the KMP algorithm says that give me this subarray and I will provide you the answer in the linear time. In the linear time. So now how would we approach to this? Okay. Think the brute force approach for this one. Brute force approach is, suppose I'm asking for index I. This is I index. So for I index, ith index, that means we are dealing with a substring 0 to I. Okay. What will be the maximum proper prefix length? Maximum proper prefix length would be I plus 1, the length of the total string, minus 1. Because proper prefix is always smaller than the whole string. So it would be I. Okay. So what I'm saying is, for ith index, move from 0 up till I. Okay, moved. Now, let me name this in this traversal at 0. That first j is 0, then 1, then 2, up till I. Okay. What we have to do is, if prefix of length j is equals to suffix of length j, then your answer for the subsequent array is j. Okay. You will say, how can you say answer? Because first 0, always a match. It will be 0. Okay. Then for 1, if matched 1. Okay. If matched for 2, it will change to 2 because if you can see that I'm moving from 0 to I. To reduce the computation time, I could move from I to 0. Okay. And whenever I find this condition true, I just break it. Correct. That is also possible. Doesn't matter. In the worst case, the time complexity for both the approaches will be same. The brute force approach is clear to you, I guess. Okay, no problem in brute force approach. I'm not writing the code for brute force. I'm just telling you in orally. If you see, we would, use it for ith index, total n indices. So O of n in the outer loop, 0 to I, O of n in the nested loop. Now prefix of length I, length j, and suffix of length j will use sub str operation. Again, O of n, it would be O of n cube, which is way greater than the brute force approach we discussed for the whole problem. So instead of reducing the time complexity, we have increased the time complexity. So we will have to discard this approach. How can we then find the pre-processing array? This is my pre-processing array. How can we find it in the less time complexity? Okay. So for that, what I'm doing is, suppose this is your string, you have to find the pre-processed array for that. This is your string. represent it as an array. This is your zeroth index. This is your first index. Moving up a while, this is your len minus 1 index. I will tell you what is len minus 1, what is the len here, okay? Just stay with me for some time, okay? After that, this is I minus 1 index. This is I index. You have to find the value for ith. And in I minus 1, we have got value as len, okay? If we find the value for I, easy task, okay? So if I minus 1 is equals to len, if ARR of I minus 1 equals to len, what does this tell you? It tells you that from index 0 up till length len, if I make a array sub array of length len from index 0, where it will end? It will end at len minus 1. So this is my index and matches the array of length len which ends at I minus 1. This is len. Okay, this is only, it says the pre-process array concept was this only. Okay, I have to get the value for I. There can be two conditions now. First condition is if, let me name this string as s, okay? If si equals to s of len, that means this string was matching with this string. Now these also match, so the length will increase. So in that case, si will be equals to len plus 1, correct? Else, that is, these are not matching. These both are not matching. So the first case that comes to my mind is if len is 0. In the else only, if len is 0. If this is 0 and these both are not matching, that means nothing in this to this range is matching in this to any other range. Say. In that case, si will be equals to 0. You are with me, right? We are on the same page. Are you able to understand me? That if this is not a match, this whole string is not a match, and these both are not a match, that means the longest common prefix and suffix for this ith index is not existing, 0 only, correct? But what if length is greater than 0? What in that case? You will say again, if these both are not matching, the answer should be 0. But no. Suppose, for example, my substring is D A B C. Okay. Again D A B C, then D. Okay. Now up till this string, you will see that uh, 1 2 3 4 1 2 3 4 matching. Okay, I made a small mistake in taking the, yeah, let me mark E here. Okay, so if you can see that D A B C E is matching, so D A, sorry, suppose your string is D A B C E D A B C D. All right, for this index, that is for this substring, what is the longest common prefix and suffix? That would be DABC. DABC. Correct? Same page? Correct. Okay. Checking for this index. You will say that this is not matching E. So answer should be 0. But if you observe carefully, this D is matching this D. So instead of 0, the answer to this index is 1. So you will say the answer is either 0 or 1. No. The answer can be anything from 0 up till len minus 1. How? As you find 1, there are many possible cases for 2 also, for 3 also, for 4 also. So what we are doing is recursion call. Recursion call for LPS of for array of len minus 1. All right. So I hope we are on the same page. You have got the gist how we are creating the pre-processed array. So let me dry run the pre-processing of array once. Though our common string example string was A, B, C, D, A, B, C. All right. Let me make an array for you. The length of the example string is 7. All right. So first, this will be always 0 discussed. Okay. Consider 6 more indexes 1, 2, 3, 4, 5, and 6. All right. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Okay. For 1, for this one, I check the 0. It is 0. Okay. 1 and 0. B is not equals to A. So this will remain 0 only. All right. This is case 2A. So I'm just explaining here. This is case 1. This is case 2A. And this is case 2B. So 1 was getting 0 because of 2A. All right. Now 2 is to be checked with 0. 2 with 0. That is 2 with 0. Again case 2A. So it will remain 0. For 3 to be checked with 0. T is not equals to A. Again 2A. 0 again. For 4 A, checking for 4 with 0 matching, so plus 1, that will be case 1. 0 plus 1 will give me 1. All right. For 5 B, 5 will match with 1, so B is equals to B, so 1 plus 1 give me 2. Now for 6 and 2, C with C, that is 2 plus 1 gives me 3. This is my pre-processed array. Okay, I hope you are with me. We are on the same page. We are winning the game right now. Okay. Now I have to use this array to reduce my computation time of solving the already matched characters with the string again and again. So our example is A, 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 B. My pattern is A, 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 A. For this, my pre-processed array will be something like this. It will contain, it will be of length 4. All right. For first 0 as usual, for 1, then 2, then 3. Okay, it's pretty simple for this. Okay, I will keep my pointer I here, keep my pointer J here. I see I is equal to J, move both of them forward. All right. Again I is equal to J, move both of them forward. Okay. Again I is equal to J, move both of them forward. Again I is equal to J, move I here, J here. J reaches the length. Let me name this length as N, name this length as M. So J is currently at 0, 1, 2, 3, 4. J is currently at 4. Okay. Now, in the brute force approach, we were moving J again to this one, this index. But now we will check. We will check for J minus 1th. Okay. We will check for J minus 1. So the next is 0, 1, 2, 3. J minus 1 is 4 minus 1, that is 3. I check 3. So it says that check from the third position instead of the first position. So index is here 0, 1, 2, 3. The third position is here. So move J here instead of here. J comes here. I A. Okay. So again matched, moves J here. Again J comes here because of the same value. I is here now. A is not matching with B. I comes here. Oh, sorry. A is not matching with B. Correct. I is not matching with J. So J will remain here only. Okay. I will go here, and the work is done. We are solved. We have got our answer as 0 and 1. Okay. Okay, I forgot to update the answer. Whenever j will come here at the index of j equals to m, we will update our answer. Update our answer as I minus j. Okay. To convert this into the one base indexing, we will use I minus j plus 1. Okay. I hope it was clear to you. I hope it was clear to you a lot. Okay. Without wasting any of the time, let's continue to the code section. Okay. Okay, guys. So continuing to our code. First, let me make some values for my future help. that is length of both the strings. Pad dot length. Okay. My len, which was using in the cases, right, that would be 0 initially, and my pre-processed array, that we name it as arr, will be of length m, first initialize it with zeros. Okay, my loop will start from 1 for the pre-processing array. Now while I is less than m, my first case was if pat I equals to pat len. In that case, what you have to do, pat I equals to len plus 1, and len also increases. Else, case 2a, that is if len equals to 0, in that case pat I equals to 0. Else case 2, that is else my len would be equals to lps of len minus lps, sorry, arr of len minus. Okay. Now you will say, why are you not writing a recursive function? Actually, I'm not updating I here in this else loop. Also, it will be I plus plus here and I plus plus here. I'm not updating I here in this else loop, so it will be a recursive function only, because whenever this condition either length equal to 0 or this condition that both of them are equal, this will be matched. So the answer will be automatically updated. That's why I'm not using a recursive definition again here. Okay. I hope you're getting my point. I hope that you are on such a level of coding right now. Okay. So after this, my aim was to use the KMP algorithm to find my answers. So for that, we were using I and j, if you remember. So my I will be 0 again, and my j will be 0. Now, while I is less than n, if pad j equals to txt of I, in that case both I plus plus and j plus plus. Now if j is equals to m, in that case move it to the answer. So let me construct a vector for answer here. Vector int answer. Okay. If j equals to m, in that case answer dot push back. As you remember, I minus j was our answer. Okay, and then j will become the arr of j minus 1 instead of going back to 1. Okay. Else if I is less than n and pat of j is actually not equals to text of I. So for that, what we have to do is, if j equal to 0, if j is at the starting position only, move I forward, so I plus plus. Else j equals to arr of j minus 1. This was our concept, right? Now, if you have paid some attention, it says use one base indexing. So it will be, instead of I minus j, it would be I minus j plus 1. And also it says if there are no correct answers, print minus 1 in that case. So for that, I will be using my Brahmastra. That is, if ans dot size equals to 0, in that case return minus 1. Else you will have to return the answer. Let's compile and run it. So running fine for compile and run. Let's try it for submit also. Running fine. Thank you guys for watching my video. Hope you liked it and hope you were able to understand it. Please understand that this is a very important question as per your interview perspective. The interviewer can just ask, then tell me the KMP algorithm. In that case, if he will be checking both of the questions, that the pre-processing array question also and the KMP algorithm also. And please, 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 I'm stressed. I cannot stress this so much that first try to tell him the brute force approach, then the optimized approach. Then only he will select you. If you will tell him the brute for optimized approach at the first, he will think that you have crammed it. Okay, so please pay attention, please keep your mind open. Okay, thank you for watching my video. And one more request, guys. I am able to see in my analytics that more than 80% of my viewers have not subscribed to my channel. So please, 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 it is very motivating for me if you are subscribing to my channel. Please, your subscription means well for me. Please don't forget to subscribe and like the video if you liked it, please. And thank you, keep watching, and don't forget to subscribe the channel for more such amazing content.